because she's running for prompting.
They did that last year.
Homecoming twin.
Yeah, I think this is really exciting.
Yeah, Mariah's late.
Yeah.
What news was
Someone
it?
in the recording should see it.
All right, let's look at this. Y'all listen up. Shh. Given Newton's second law, force equals mass times acceleration. Solve for acceleration. We're going to do this all year. Here's your formula. Force equals mass times acceleration. Notice in the problem I put a little asterisk there. That means multiply. So mass times acceleration.
No, X is gone. We now use dots.
Recording.
Oh.
So how do I solve for acceleration? Solving for acceleration means I want to get acceleration all by itself on one side of the equal sign. How do I do that?
Divide by mass.
Divide out mass. I have to get rid of mass. Whatever I do to one side of the equation, I have to do to the other side of the equation. So I'm going to divide out mass over here. Where's the microphone speaking to? It's in my computer. So, acceleration is equal to force divided by mass.
That's the answer?
Yeah.
Yes, ma'am.
I don't think this was the right one.
Yeah, I think you should be done.
What?
Example B. Sammy Sosa swings at a .15 kilogram baseball. .15 kilogram. What variable is that?
Mass.
Good. And accelerates it at a rate of 30,000 meters per second squared. 30,000 meters per second squared is what?
Moving.
Acceleration.
Acceleration. How much force does Sosa exert on the ball? This one is very straightforward. Force equals mass times acceleration. Mass is 0.15 kilograms. Acceleration, 30,000 meters per second squared. Watch how I write this. I'm going to write it meters over second squared. It means the same thing. I could also put 0.15 kilograms over 1. Now I'm multiplying fractions. 0.15 times 30,000 gives us 4,500 kilogram meters per second squared, which is also known as a Newton. Good. 4,500 newtons. Example C. Gunter, the weightlifter, can lift a 230 kilogram barbell overhead on Earth. Okay, 230 kilograms. What variable is that?
Mass.
The acceleration due to gravity on the sun is 274 meters per second squared. There's an acceleration. A. Would the barbells be heavier on the sun or on Earth?
Sun. Earth.
We said that heavy or weight is the same thing as what?
Gravity. Inertia due to gravity.
Force. And force is mass times acceleration. Well, the mass is 230 kilograms. Acceleration on the sun, that's A with a subscript of sun, is equal to 274 meters per second squared, which is greater than acceleration due to gravity on the Earth, which is what? 9.8 meters per second squared. So it's going to be heavier on the sun. Okay, And then B, how much in newtons would the barbells weigh on the sun if it were possible to stand on the sun without melting?
Because you always have that one kid in class.
Yeah, exactly. Okay, so how much would it weigh? How do we find out?
Mass times acceleration.
Mass times acceleration. So that's going to be 230 kilograms, that's our mass, times 274 meters per second squared. It's going to be 63,020 kilogram meters per second squared, which is a newton.
Yeah.
Good. Okay, I'm going to give you help on the practice problems. Number 1, given the following equality, calculate your mass on Earth. So you put your weight in pounds over 1, and you multiply by this equality set up in a fraction. How are we going to set it up?
2.2 over 1? Or no, 1 over 2.2.
1 kilogram per 2.2 pounds. Pounds will cancel.
So we put our weight on top.
Yes. Number 2, Danny the soccer player weighs 150 pounds and is going to compete in the first lunar soccer game. Calculate Danny's weight on the moon given that the acceleration due to gravity is 1.62 meters per second squared. So first, you're going to convert the weight to kilograms. Then, once you have the mass, you're going to say that weight is given by mass times acceleration. Three, Felicia the ballet dancer has a mass of 45 kilograms. What is Felicia's weight on Earth? So first, you just convert kilograms to pounds. And that's all you do for A. And then B, what is Felicia's mass on Jupiter, where the acceleration due to gravity is 25 meters per second squared? If her mass is 45 kilograms on Earth, what's her mass on Jupiter? 45 kilograms. It's a trick question. Number 4, during a hockey game, Andy skates into a teammate with a force of 100 newtons. What is the acceleration of Andy if he has a mass of 75 kilograms? Well, force equals mass times acceleration. We want acceleration, so we have to solve for acceleration. So acceleration will be given by force divided by mass. What is the acceleration of his teammate if he has a mass of 83 kilograms? It's the same formula. You use the same formula. And you use the same force, because whenever they collide, Newton's third law applies. What's Newton's third law? Good. For every action, there is an equal and opposite reaction. If Andy collides with 100 newtons, then his teammate is colliding with 100 newtons. So it's the same force. Okay, that's all the help I'm going to give you. I'm going to see if y'all can work on it from there.
Are we working on this one?
We're going to take the quiz now.
Are you kidding me?
Ever.